Hello everyone from Math 2200, Discrete Mathematics. Professor Wenson here again with a video on your Zybooks, section 11.1. It's titled Generating Permutations and Combinations. So this should be a relatively simple section. You're going to be taking basically a list of numbers and telling me what the next list of numbers in an order would be. You'll see when I go through the section that it should be pretty simple. Alright, so the two optimization problems described below illustrate situations in which it is necessary to generate, not just count, all the permutations of a subset or of subsets of a given size. So like a company has 100 employees. For every pair of people, the managers know whether those two people are compatible. The managers would like to find a group of 25 people to work together on a project such that every pair of people in the group is compatible. One approach is to finding such a group is to enumerate all 25 subsets of the 100 employees and check whether, everyone in the group is mutually compatible. Another scenario. A package delivery service must deliver 20 packages to 20 different locations. What is the best order to deliver the packages that minimizes the total distance traveled by the driver? One approach to finding the shortest route is to enumerate all permutations of the 20 locations and calculate total distance traveled if the driver delivers the packages in the given order. Alright, so the first concept we're going to run over is lexicographic order. Now this just means like dictionary order. Dictionaries are in lexicographic order when it comes to words, of the English alphabet. So you're ordering permutations and ordering combinations in kind of a dictionary style fashion. Alright, so a well-defined order imposed on the n tuples is useful to systematically generate all the elements in a set of n tuples. Generating the n tuples in the set from smallest to largest ensures that each n tuple is generated exactly once. Lexicographic order is a way of ordering n tuples in which two n tuples are compared according to the first entry where they differ. Words in a dictionary are ordered in lexicographic order. For example, the word comment appears before the word compare because the first place where the two words differ is the fourth character, and M appears before P in the alphabet. And you're going to be doing something incredibly similar with numbers here. Although words of different lengths can be ordered lexicographically, this material only compares n tuples of the same length. Alright, so consider two different n tuples or permutations, P1 through Pn and Q1 through Qn. To determine which n tuple is considered smaller, the n tuples are scanned from left to right to find the first index where they differ. Suppose that k is the smallest index such that pk is not equal to qk. If pk is less than qk, then that permutation, that n tuple, is considered less than the other one. Otherwise, it's considered greater than. Right? So look at their examples here. Here are some 6 tuples, right? Some permutations of 6 elements. Got 9, 5, 2, 4, 9, 5, 2, 4. So they're the same in the first 4 places. But then the 5th position, see 5 in this 6 tuple, 3 in this 6 tuple, 5 is greater than 3. So then they would consider this 6 tuple greater than this 6 tuple. It's almost like just comparing numbers in decimal places. here 1, 100, 102, 2, 1, they're different in the first place, and 1 is less than 2, so this 3 tuple is considered less than that 3 tuple. Very, very simple, I feel. So would this n tuple be considered less than this one? Yeah, look, they differ in the first place, and in that first place 2 is less than 3, so this 5 tuple would be considered less than that 5 tuple. That is true. Here they both, these are both 6 tuples. Starts 2, 1, 2, 2, 1, 2. Then the fourth position, 3 and 7. 3 is less than 7, so this 6 tuple would be considered less than this 6 tuple, yes. 2, 1, 23, is that less than 2, 1, 4? No. Right, they're the same in the first two positions, but the 23 is greater than 4 in the third position, so this 3 tuple would be considered greater than that one, not less. Alright, so hopefully that was easy enough. Alright, now we're going to be asked to generate permutations. Right? So basically putting permutations, putting tuples in order, in lexicographic order, dictionary order, from least to greatest. So remember, a permutation of the set 1 through n is an ordered n tuple in which each number appears exactly once. So 2, 5, 1, 4, 3 is a permutation on the set of elements 1, 2, 3, 4, 5. All right. I remember the parentheses mean permutations. Parentheses around this list mean that order matters. Right? It's a permutation. Any two distinct permutations can be ordered lexicographically. Generating permutations in lexicographic order is a good way to ensure that each permutation is generated exactly once. The first permutation in lexicographic order is just, put them in order, 1 through n. And the last permutation is put them in reverse order, highest to lowest, n through 1. So they give you here the permutations of 1, 2, and 3 in lexicographic order, right? The lowest would be 1, 2, 3, then 1, 3, 2, then 2, 1, 3, then 2, 3, 1, then 3, 1, 2, then 3, 2, 1, the highest. Right. So they discuss how to do that down here, right? So let's just think. Which permutation is the first in the permutations, the 5 tuples reordering? It's just 1, 2, 3, 4, 5. That'd be the lowest. Which is the last, 5, 4, 3, 2, 1. And then which one of the choices given is the next permutation after 5, 2, 4, 3, 1 in lexicographic order? Well, 5, 2, 4, 3, 1 would be actually greater than 5, 2, 4, 1, 3. So that's not next. This is before it. Now 5, 2, 4, 3, 1 would be less than these two because the second position is 3 instead of 2. And then of these two, the smaller one is this one, 5, 3, 1, 2, 4. Right, so 5, 3, 1, 2, 4 would come next if you were putting these permutations, these 5 tuples, in order from least to greatest, right, in this lexicographic order. Now they talk about a little procedure how to do that in this animation, and I'll show you. So if I said, what's the next permutation after 2, 7, 3, 6, 5, 4, 1? So here's the procedure, right, to very systematically get the next one in lexicographic order. So you move from right to left until the current number is less than the one before it. So 4 is greater than 1, 5 is greater than 4, 6 is greater than 5, but here 3 is less than 6. So that digit that's smaller, find the smaller now find the smaller number after 3 to the right that's greater than 3, which would be 4. Right? So looking to the right of 3, the smaller number after 3 that's greater than 3 is 4. You swap them, and then you reorder the numbers after it. So make that 1, 3, 5, 6. And there you go. There's the next permutation. And it's really that simple. Once you're given a permutation of so many objects, so many numbers, to find the next one in lexicographic order, again, you move from right to left until the left number is smaller than the right one. So that's 3, 6 here. Then take the small number, find the number to the right of that that's, the smallest number to the right of that that's bigger than it, and swap them, and then reorder all the numbers after. All right, so they do it again with here. So you see here, 2 is less than 5. So great. So I switch the 2 and the 5 basically, and then you're done. Because that would be all that would have to be done. And there, 1, 3, 4, 5, 2 would be the next permutation after 1, 3, 4, 2, 5. All right, so let's try that out. Let's try that out here. All right, so I'm going to write this on some paper. So we're given this permutation of six numbers: 1, 5, 4, 2, 3, 6. And they simply ask us, what's the next one, the next highest one in lexicographic order? What would be the next largest? So again, from right to left, I start comparing two numbers. And then, 3 is less than 6. So there, I'm done. I can stop. I don't need to move to the next two. And I take the smaller number. I look to the right of it, and what's the smallest number that's bigger than 3? Well, that would be 6. And then you just swap those. All right, we swap them. So it'd be 1. So this would be less than, right? This permutation would be less than this permutation, this n tuple, 1, 5, 4, 2, and then switch the 6 and the 3, 6, 3. And then once you swap them, then numbers after that 6, you just reorder them. But there's only one number after the 6, the 3, so there's no reordering need doing. So it's 1, 4, 5, 2, 6, 3 would be the next highest n tuple, the next highest 6 tuple. All right, so let me do that again. All right, let me do that again. All right, so the next one is another 6 tuple. So 2, 1, 4, 6, 5, 3. All right, and again, what would be the next highest? The next highest, well, let me save that for later. The next highest permutation. So again, these two, the left is bigger than the right, so keep moving. Left is bigger than the right, keep moving. All right, this time this number 4 is less than 6. So now, to the right of 4, I look for what's the lowest number higher than 4 to the right of 6, and that would be 5. And then we're going to swap these. Okay. So I swap those, and that gives me 2, 1, and then 5, 6, 4, 3. And then after the swap, right, take the numbers beyond that swap position, beyond the 5 here, and reorder those from least to greatest. So instead of 6, 4, 3, I'm going to make that 3, 4, 6. So from this permutation, the very next one in lexicographic order would be 2, 1, 5, and then 3, 4, 6. This would be the next one after this one. 2, 1, 5, 3, 4, 6. That's this here. All right, so I'll leave this one to you. Okay. Well, actually, it'll just be 6, 5, 4, 3, 2, 1. Okay. Oops. Sorry. 6, 5, 1, 2, 3, 4. Yeah, switch the 6 and the 5, and then reorder the rest. Right. Okay. Yeah, switch 6, 1, 2, 3, 4, 5. All right. Yeah, pretty systematic way of doing it. All right, I just kind of rushed that last one. All right, so again, you're given some here. You're just asked to put them in order from least to greatest, the way that we were ordering them a second ago, and you're doing that for I think all 4 levels. Yeah, same thing. Given these 5 tuples, asked to put them in order from least to greatest. Now they're saying what would be the next 5 tuple. So 2, 4, 5, 3, 1. Let's see, that's greater, that's less. So I'd switch 4 with the 5. That'd be 2, 5, 1, 3, 4. 2, comma 5, comma 1, comma 3, comma 4. Right? So again, pretty straightforward. And I think the next one's the same. Yeah. So what would be the next 6 tuple here, 7 tuple here in lexicographic order, following those same steps. All right. So now, all right, that was all generating the next, permutation, the next tuple where order and position matter and all that. Now we're going to generate subsets, right? So this is going to involve braces instead of parentheses, right? So unlike sequences or n-tuples, the order in which elements of a set or subset are written does not matter, right? So the set with 6, 2, and 8 is the same, is equal to the set with 2, 6, and 8, right? Again, the curly braces mean it's a set and order doesn't matter. Now, sets can also be ordered lexicographically by first sorting the elements in increasing order and then comparing the two sets as if they were ordered sequences, right? Kind of like the tuples earlier. Consider as an example, the two sets 3, 11, 2 and 5, 6, 2, 6, 5, 2. Well, again, I just reorder them. That's 2, 3, and 11. This is 2, 5, and 6. And then, their first elements, when they're reordered, are the same. Their second elements are 3 and 5. And 3 is less than 5, so this first set would be considered less than this next set. Right? So pretty similar. So here, this set with 3, 1, 6, and 7, I would reorder this to 1, 3, 6, 7. And this is 2, 4, 5, 6. That's already in correct order. And the lowest element here is 1. The lowest element here is 2. So this set would be less than this set, not greater. Right, so it all matters on putting things in increasing order and then comparing the elements. All right, so I'll leave you to these examples with some 4 subsets. All right. Now, what we're going to do next, the next algorithm takes as input 2 natural numbers r and n, such that r is less than or equal to n, and outputs all the r subsets of the set 1 through n. The elements in a subset are always listed in increasing order. Here, the subsets are generated according to lexicographic order to ensure that each subset is generated exactly once. So the first r subset of the set 1 through n would be the set 1 through r, right? Just the first r elements. The last r subset would be n minus r plus 1 up to n, right? The last r elements when in order. So their example here are the 3 subsets of 1, 2, 3, 4, 5 listed in lexicographic order. You start with 1, 2, 3, then 1, 2, 4, then 1, 2, 5, then 1, 3, 4, 1, 3, 5, 1, 4, 5, 2, 3, 4, 2, 3, 5, 2, 4, 5, and finally 3, 4, 5. Here's all 10 3 subsets, right, of the set of 5 listed in this lexicographic order. And what we're going to be asked to do is, when we're given one r subset, what would be the next one in this lexicographic order? All right, so what is the first output of this, choosing r subset? Now, this is 4 subsets out of a set of 9, so the first output would be 1, 2, 3, 4. The last output would be 6, 7, 8, 9. Right, the last 4 subset out of 9 elements. And then if the set 2, 5, 6, 9 is output, and then you go through this algorithm here, what would be output next? Well, 2, 5, 6, 9, the next highest would be not, I can't go higher than, I can't bump that one up higher, but I can bump this one up higher, 2, 5, 7, 9. Oops. 2, 5, 7, and then 8 would be lower than 9. Right? Yeah, the next one. And again, I rushed that one, but there's a nice algorithm, a nice way to do it that they're explaining again down here. So again, if I'm selecting, say, 6 subsets, subsets of size 6 out of the elements 1 through 9, and they say, what's the next one in lexicographic order? So again, I move from, put them in order from least to greatest, and then move from right to left until the current number can be increased. So you see 9 can't be, because I've already used 9. 8, I can't bump that up to 9 because 9's already used. 7 can't be bumped up to 8 because it's already used. But 4 can. So I would change 4 into 5 and then go 6, 7, 8. And just go the numbers consecutively after 5. So again, 9 can't be used, 8 can't be used, again, 7 can't be used, again, bumped up. But 4 can be. 4 can be. So I increase that by 1 and then use the digits after it until I complete the 6 subset, right? Use 6, 7, 8. And that'll be the next combination, the next 6 subset taken from elements, a set of 9 elements. Then do another example. What would be the next one here? Now I can bump 8 up to 9, can't I? So I can bump 8 up and make it 9, and that would be it. That would be the next 6 subset in lexicographic order. So very simple, that one. Alright, so let me do an example in this next activity. Right. So here, subset 3, 4, 7, 8, 9 is chosen from the elements 1 through 9. What 5 subset would come next in this lexicographic order? So back to the paper. Again, the set we're choosing from is the set with elements 1 to 9. All right, and we're choosing 5 subsets, subsets of size 5. Now the subset they gave us is the subset with 3, 4, 7, 8, and 9. So again, I work from right to left. Can I bump this up 1? No, I can't. There's no 10 in this set, and 9 is already used. Can I bump this up 1? 9? No, it's already in there. Can I bump this up 1? No, 8, it's already in there. Can I bump this up 1? Yes. So I'm going to change this to 5, bump it up by 1, and then the rest of these just go 6, 7, 8. Just go the ones after 5. Just keep adding 1 until you fill in the whole subset, the 5 subset. So the next highest one, after the next subset, the next 5 subset in lexicographic order would be 3, 5, 6, 7, 8. Let's go back here. 3, 5, 6, 7, 8. There we go. Here's another one, same thing. You're pulling from 9 elements again, and it's another 5 subset. So I'm going to go back. So this is a totally separate one. So they gave us this subset of 3, 4, 5, 7, 8. All right, there's a subset of 5 elements taken from 9. Can I bump that up 1? Yep, I can. Change to 9. And then everything after, there's nothing after that, so that's it. 3, 4, 5, 7, 9 would be the very next element, the very next 5 subset in lexicographic order. 3, 4, 5, 7, 9. Then again, this one, can I bump up 9? No. Can I bump up 8? No. I can bump 6 up to 7 and then just go 7, 8, 9. So 3, 4, 7, 8, 9, blam. All right. Again, pretty simple stuff, I feel. All right, so this one is put the subsets in order, in lexicographic order. Just make sure to rearrange the elements in the subset first. Right? The next level, same thing. Put these in order. Then what would be the next one? All right, so again, 3, 4, 8, 9 from set 1 through 9 again. Can't bump that up, can't bump that up. That would be 5, right? So 3, 5, 6, 7. 3, 5, 6, 7. All right. So again, very quick and easy once you get the hang of it. And the last one, same deal. Right. And that's it. Right. That's it. Then you have your additional exercises. Again, some of these are assigned, some are not. I would still recommend looking at all of them, right, just to get more exposure to the material, more practice, get better at it. And you got the solutions to look at if you need to. But please, try to work them out, try to figure them out first, and then look at the solutions, right? Don't just copy solutions down without trying the problems. You're not going to learn anything that way. And if you have any questions, of course, send me a message and I'll get back to you as soon as I can. And thank you very much for watching.